Square roots and cube roots. The graphs of them, that is. Let me show you first what they look like versus cube roots. A square root graph has, I call it a starting point, and another point that is a directional point, okay? It looks like, think about it as half of a parabola on its side. Okay, if you were to take a parabola like this and turn it and cut half of it off. Okay, so whenever it goes this way, when that number in front is positive, it looks like this. Evan, you don't need your computer, dear. And then if that number in front is negative, it flips it so it could look like this. But it is bounded there, because when you think about square roots, we can't have a what under the square root? A negative. We're on a real number plane, so we're not going to have any negatives.
Wait, can you explain that again?
So a square root is the inverse of a quadratic, okay? But because we can't have a negative under the square root, when you take that, what is it? When you take that parabola and you turn it on its side so it looks like this, because I can't have a negative under it, it's only this part, if that makes sense. So I could have it, if it's a positive in front, like that A is positive so the parabola opens up, or if the A is negative so it's upside down like this, then it would flip the other way and I'd end up with the bottom portion of it. Just trust me. I'll show you. I'll show you in a minute. It'll make more sense in a minute. All right, so then a cube root. I don't have any restrictions on a cube root, right? What do you think the inverse of a cube root is? A cube. A cube. So if you take a cubic graph and you switch x and y and turn it on its side, it looks like this. There's one in every group. Or Colin's trying to take your job. Or like that. Okay, so it flips. Whether the A is positive or negative determines if it flips which way. Okay. This one, you need 3 points to graph it. You need this middle point, and then you need a point on either side so you can tell which direction it goes off in. For a square root, though, you only need 2 points. You need to know the point it starts, which would be like the vertex of the parabola, and the direction point, the direction in which it goes off. So you need 2 points for a square root graph. You need 3 points for a cube root graph. Looking at the square root graph, what is restricted on that? Or is anything restricted? Huh? Think in terms of domain and range.
Yeah.
The domain and the range is restricted, right? Here it doesn't go any further left than that, so that's a domain restriction, and it doesn't go below that either, so that's a range restriction. So we're going to have a restricted domain and range. How about the cube root?
There's a domain restriction.
Domain restriction, no range.
Neither. It's neither. It doesn't have any restrictions on either one. This is creeping up the whole time and creeping down the whole time, so the range is not restricted. And the domain, obviously, you can plug anything in. I can put anything in a cube root, right? Positive or negative?
Sure.
Not sure, yes.
Yes.
Okay, yes, that's the correct answer, yes. All right, y'all ready to graph them? You want me to show you what they look like? Let's do square roots first. I'm going to start with the parent graph and show you, but let me put the variables in here first.
What graph?
Parent.
What does that mean?
Without any transformations to it, it's just the square root of x. It hasn't been flipped, it hasn't been shrunk or stretched by a, it hasn't been slid by h or k. And we haven't talked about transformations a lot, but you'll talk about that a lot in pre-cal, so I'd like to kind of introduce it to you too. All right, this is an easy graph to talk about transformations for because it's really easy to see. Well, remember when we had when we had parabolas. Okay, and we had the forms of the equations for the quadratics. So x minus h squared plus k, or x minus p, x minus q, that kind of thing. It's the same thing here. That's what the letters, they're going to represent something for us here. Okay, but the A shrinks or stretches the same way that it does in every other thing that we do. It also tells us up or down. Okay, if it's going to be this top half of the parabola or this bottom half of the parabola. And what the H and K do, we've talked before that the H and the K are the vertex, okay? But what that really does, and it does give you the vertex, and it's still going to give me the vertex. It's going to give me the, yeah, the middle point, that point right there. HK is still going to be, H is opposite, remember. That's still going to be like my vertex, but here I'm going to call it my starting point. But what it does essentially is it slides the graph. The H gives me a horizontal shift. Sorry. I'm calling it a horizontal shift. In geometry, you call it a translation. Okay, it just shifts it left or right. So this is my horizontal shift. This is my vertical shift, because the parent graph, let's see here. The parent graph is square root of x. That's when h and k are 0 and a is 1. Okay, so it starts out with a vertex of 0, 0, or a starting point of 0, 0. So H tells you how to slide it left and right, and K shows you how to slide it up and down. And we'll talk more about that later. I just really felt like I needed to talk to you about some translations and some shifts for just a minute. So with that said, let me show you how to graph them. I'll give you a second. All right, here's what we're going to do. We're going to take this equation. Let's say we have the square root of x plus 1 minus 5. Okay? We're going to find our starting point. Our starting point is hk, but what we're going to do is we're going to have to change the sign of h since it was minus h. So what is my starting point for this one? -1, -5. Essentially, that is my, remember, this is the inverse of a parabola. Inverse means I switch x and y. So I've taken that parabola that was opening up, I've twisted it over on its side, and I'm taking the top half of it. So the vertex of the top half of that parabola is -1, -5. How many points? And I'm going to put an S here so I know that that is where I'm starting. Okay, or a V for the vertex, whatever you want to do. So now the question becomes, how do I get my second point? I told you you need a 2 to graph. I need a start point, and I'm going to call the other point a direction point because I need to know how high up or down low and which direction to go with this. I know what it's going to look like past that. So what could I do to find another point? Easy point, an easy point, and I'm going to plug it in. You're both exactly right. So if I'm at -1, what's an easy point? 0. If I want to know where,
What does that say?
the further away, just like with, you could, but the further away you get from that starting point, just like when we were doing parabolas, the funkier the number gets. Okay. All right, so I'm going to plug in. Somebody asked something else. What'd you say? What's square root of 1?
1.
What's 1 minus 5?
-4.
What's that point?
-1.
What'd you plug in? This is my direction point, which means I put my pencil on the starting point and I connect in that direction just like the top half of a parabola. Does that make sense to you?
Yes.
Looking at this graph, what is the domain of my graph?
-4? No, 1. -1.
-1 because that's my x value up to what? Positive infinity. What gets brackets and what gets parentheses?
Infinity is parentheses.
Infinity gets parentheses always and forever. How about the -1? Bracket because there is a point there. Does that make sense, boys? Yes. How about the range? -5 because that's the lowest point up to infinity. Bracket. Does that confuse anyone? Don't forget domain and range.
So that was going to be infinity?
Yes. Because it goes up forever.
So your domain is how much it goes this way?
Left to right, right. And your domain and range restrictions are coming from that starting point. Yes.
I'm saying, like, oh, so they're always forever going to be infinity after that.
For square roots, yes.
Okay.
For square roots, yes. Let's do another one. What's the start point?
0.
0, 2. That's right. Why is it 0?
Because there's not a thing behind the X.
There is no h. That's right. H always stays under the radical. K always stays outside the radical. H is under, K is outside. So it's 0, 2. Now for the direction. Plug in 1 because that's right beside the 0. If I plug in 1, I get the square root of 1 plus 2. What's the square root of 1? 1. And 1 plus 2 is 3. So it's 1, 3. That's direction. I connect them. What is the domain?
0.
0 to infinity. How about the range?
2.
Mm-hmm. Yes or no?
Yes.
All right, let's do cube roots. All right, cube roots. The graph, I told you it looks like this. Right? I need 3 points. I need a start point. And I need 2 direction points. Direction 2. Start's going to be in the middle. It doesn't matter which one you make direction 2 and which one you make direction 1. Just make one each, okay? We're going to go either side of the start point this time. So let's say I have y equals the cubed root of. And by the way, this is different than this. And if you do not specify on your test, you may get it wrong. Okay? This is saying 3 times the square root of. This is saying the third root of.
It works the same way as square roots, except you're doing.
Yep.
So it's 2 cubed.
Yep. So the start point here, yes.
Is that 3 the A or is that in the cube?
It's in the cube. That's the third root.
Okay.
So 1 is A.
Yeah. 1 is 8. That's correct. All right, what's your start point here? 2, 2. Opposite sign again. I need 2 easy points.
1 and 3.
1 and
3.
1 and 3. Why did you pick those 2?
Right beside 2.
They're right beside 2. I need either side of them. So when I plug in 1, and as long as you stay right beside it, (1 minus 2). What's 1 minus 2?
Negative 1.
-1.
Times 1 times 1.
That's right. What's the cube root of -1? -1.
-1 times -1.
Oh, okay, okay.
Is that a 2 or 1?
Hmm? The cubed root of -1 is -1 plus 2
Where
is
you
1.
wrote over the 1 with a 2.
Oh, that's a 2.
Oh, okay.
Sorry.
Like, I don't know this
It's just
number.
around
I
2.
look and
It's the numbers above and below 2. It's 2. 2 is the start.
If you start at 2, you need to add 1 and then you need to subtract 1. Plugging in for 3, I get 3 minus 2 plus 2. 3. So I get 3, 3.
Just 1, 1, and 3, 3.
Yep. How about domain?
negative is
I told y'all this was easy. Range.
A negative 3.
Wait, how?
Do not mistake it though, because as easy as it is, this is what the majority of you will miss when it comes down to a cumulative test or test. Because you look at it, think it looks easy, and then you don't look at it again.